let's then take a look at what reliability means when edge is a critical part of the infrastructure. What is the cost to the customer in hardware, labor, and lost productivity? It's very important to measure what downtime really means to a customer, right? And how much does 1 hour of downtime actually cost? I know, Cole, that you have worked with some customers and actually looked at some of this cost analysis. You want to share some of the data there?
Absolutely. And this is one of the most important questions you need to ask yourself when doing an edge deployment is, something I've seen time and time again is that, folks don't necessarily consider what the total cost of ownership means for the hardware and the overall solution stack. It can sometimes be easier to say, if we implement this kind of application, from the software side, we will save this much money from reduced downtime or improved operating efficiency, what have you. That can sometimes be easier, it can sometimes be complicated. But sometimes I feel that people, and what I've seen is that piece of the puzzle, the total cost of ownership of the hardware, sometimes gets ignored. And it's the reason why we specialize in this type of hardware, because there are these new challenges you have to present. And if you deploy the wrong hardware, to give a quick example, and then I'll really tell a good story here for you guys. If you're deploying a desktop tower, you bought let's say Best Buy, you went out to Best Buy, you bought whatever you saw the sales guy directed you. If you deploy that in a factory, you're gonna have issues. And it's just a matter of how much are those issues gonna cost you. A desktop computer isn't designed to be on 24/7 in terms of the components it's put into it. It doesn't have the environmental protections. And really, when you look at it, an hour of downtime, the cost can vary. I've heard anywhere from $50,000 on the low end per hour to well over $1 million. You look at I think it was 2019, Samsung had, I think, a 3-hour outage at one of their plants in Korea, and it cost them $3.6 billion. So, for a large organization, it's even worse. But to give an example of how this applies in the real world, I was working with a company out in, and I'm not going to name names here, but I was working out in the Southwest United States. They were deploying a cheap PC at the time that really wasn't meant for the environment that they needed it for. And actually, they weren't using Ignition. So we were able to bring in Ignition too, and it simplified their software stack. So they saved even more money. But there was one really big problem for their cheap PC. They would fail all the time. They did not pick a system that was designed to go out at the edge. So every time this happened, they'd ship a system out to a motel. The tech would drive, I think it was from Dallas, he would drive out to the middle of nowhere. He would pick up the system and he'd either sleep there or keep on driving. He'd go fix the problem, ideally. Sometimes he couldn't, he'd get more parts, so then he's out there for even longer. And then he drives back. So they come in, they're saying, well, we want a system that's at this price point. I say, okay, let's just do a quick, the quick math here. You, by going with a system that wasn't designed for that environment to save a little bit of cost, let's say the price, I can't remember the exact price delta, let's just say $400. They save $400 deploying these over, what would be an equivalent system of ours. You've now cost not only 2 of those systems, but 2 days of the technicians full time, all their expenses, the downtime at that remote facility. So a lot of times when I have this conversation of, well, we're deploying something today and it's really not working, the cost is actually hundreds of thousands of dollars of lost productivity. There's a great case study on our website from a company called American Woodmark. They were paying someone's full-time job to go out and vacuum desktop towers. They immediately were able to reprioritize that technician to switching us. So they were saving immediately. They turned a very, repeating menial task. That was now a full-time technician that they basically had all free time of theirs. So it's really, really valuable. And I think, I'd like to give it over to Mike, and he'll talk a little bit more about those considerations and what's important.
Yeah, and one quick thing to kind of interject here is we look at, when talking to customers as well, is making sure that we have the right hardware so that we can scale Ignition, right? That we could do more with Ignition. But it kind of reminds me a lot of what my parents would tell them when I was younger. about buying the right pair of shoes, right? Yeah, you can go get a cheap pair of shoes, and you're probably going to replace it because you're super hard on them. When I was playing sports every single day, it's a similar kind of thing. It becomes critical as part of the overall infrastructure. It becomes an important piece to it. And long-term ROI, you're going to gain by thinking of the applications and the value of the data that we're dealing with, not so much that initial investment. Yes, there's investment, but the point is to make that investment because it will protect that future. So I know I didn't want to steal any thunder there, Mike, but I want to mention that before you go in those considerations. The considerations are really important here.
Yeah, absolutely, Travis. Thank you for that. I'm going to take a few minutes just to kind of walk you through some things that you should think about, things that we've hit upon that can help you make the right hardware selection and avoid some of those issues that Cole talks about. First, environment. Environment's a huge thing. Dirt, dust. I'll extend the example that Cole gave. My father-in-law worked in Florence, South Carolina as the head of manufacturing. They had to do some data input next to a metal lathe that shot out tons and tons of metal shavings. IT brought down a desktop fan computer and put it next to that, and you can imagine the sparks that came out after about 3 minutes. So it was exciting. My father-in-law was not pleased, and they learned very quickly about fanless computers as a result. We have people that have got fiberglass shavings and everything else going on around. Temperature variability, you may think, okay, I'm in an indoor environment and I'm good to go, but I worked in a non-temperature controlled warehouse when I was a teenager. We used to joke that it was air conditioned in the winter and heated in the summer. And I mean, that was extreme, even being indoors. But then you take that out to the top of a wellhead in a Texas desert, sitting on an oil rig, and you've got a completely different perspective. So take your time, really think about, not what's going to be the common condition, but what are the extremes that you're going to face. Power input, AC power is not everywhere. AC power is great. You can plug a power adapter in, a conditioned brick, give you good clean power to your system. We offer that. But if you're in a vehicle, if you're on a forklift, if you are in auto, all those kinds of things, you're probably running DC power. It may not be the cleanest. So make sure that you're thinking about power protections. How clean is my power? Is the system that I'm going to select will it be able to deal with that kind of stuff?
Yeah, and looking at one of the most common use cases there with, running it in an enclosure, you have a 24-volt supply you're using to power everything. If you've got terminals on that, you want a system that's got terminals on the other side so you can wire it up very simply. And, that's something we've really gone a long way in the last couple of years of really standardizing on it.
Yeah, absolutely. Impact forces and vibration, rail, auto, forklift again. Cole and I were just joking about, we just got one of our K800 units that came back off of a forklift that somebody ran into a whole bunch of stock. It doesn't look so great. Works real well, but doesn't look so great. So think about, your folks don't always treat things super nice. If you're going to be putting this onto a Mack truck that's working in a quarry kind of a thing, doing 5G data transmission, again, what's your worst case? Chemical is one that we really don't think about a lot. But if you're in we've got a client that's a car wash, we've got people in manufacturing, we've got people that at the end of the day, they've got to spray down their equipment with caustic chemicals. Again, what is your typical screen going to look like after being sprayed by caustic chemicals? So these are all important things. Then finally, embedded life cycle. A lot of folks are going to want to standardize on a PC that they can image, support, train people on, and it's going to be out in the field for a long time. So really think about, in the commercial consumer space, you're looking at Dell, HP, those kinds of folks introducing a new model every 6 to 18 months. You're looking at more of a 5 to 10 year life cycle in a lot of cases. So just things to think about. IO, I can touch on this super fast. It would be a wonderful world if everything was connected with high-speed Ethernet. Not the case. When I walked into that manufacturing plant, there were still PLCs and things that were 20 plus years old. Serial connections, to being able to interface with those using the inductive software with drivers that are built in, all that's really critical. Think about how many
pieces, how many IO connections you need. Think about what variety. Look for a cost-efficient way that your system provider can configure that way for you. That's one thing that we really pride ourselves on. You know, as Cole said, we build to order. We give a lot of options on the front end. If it gets a little overwhelming, just give us a call. Our sales folks will be glad to walk you through that. But really think about that modularity. Make sure that you can meet your needs at a good price point. Regulatory compliance. I am learning more about this every day. I'm a former software designer and we didn't have to worry about these things. UL, safety, certain industries, medical, you know, very, very stringent requirements. This is the one thing that I've seen derail more deployments than anything else, is they get deep in and then somebody goes, oh, hey, you need to worry about this. And, you know, a lot of times we can kind of scramble and reconfigure and do things like that. But I mean, Cole, I know you've run into so many times as sales engineer.
Absolutely. You know, I think it's not something that I think is often discussed. You know, one of the things I'll hear, well, I never got that other question from your competitors. I'm like, well, it might not be something that derails your project now, but like I've seen, like Mike said, it's like 11th hour, you're going to have issues. If you talk to us up front, you know, we've got a number of systems that can easily be, you know, UL industrial IT equipment rated right out of the box. We just give you a custom label and a custom configuration. You order that, you'll always have a UL rated computer. But stuff like getting into specific countries, you know, we cover North America, Europe, you know, Australia, New Zealand easily, and Japan for most cases. It's not something a lot of people think about of what does it take, or where am I deploying? What does it take to get my PC hardware in there? If you're trying to deploy to, you know, South Korea without the appropriate markings, it's going to get rejected at customs.
Yeah.
So it's something to consider up front, and you know, something that, you know, we have an entire team dedicated to helping customers solve the challenge.
Yep, and trust me, I appreciate having that team around here because it is very, very complex. Okay, mounting, just a couple of quick words. You know, some environments, you'll be very safe to put your PC right on the back of your monitor using a Visa mount, maybe a wall mount, something like that. Industrial situations, you're probably gonna have something more that looks like the DIN rail that's pictured here. Think about enclosures. Think about what's gonna happen as far as heat inside that enclosure. Think about your spacing. Think about, you know, attention to form factor, dimensions, those kind of things. You want to be able to close the doors, obviously. Things like HMIs are another thing to think about. You know, are you going to have your panel PC flush with the face of your enclosure? What does that mean? What does it mean in terms of access? All those things are things that you need to think about ahead of time to make sure that you've got something that's not only usable, but also maintainable and supportable. And then finally, like, you know, Cole said, we do have some servers, edge servers that have got more processing power. You'll find those in a rack mount option, but the vast majority are going to be in your more traditional mounting options. And then I think this is my last slide is connectivity, and connectivity is huge. It's one thing to have the data, but by goodness, you better be able to get access to it. Industrial atmospheres, noise, you know, electrical interference, all those kinds of things. Hardwired Ethernet will always give you the best results. But there's plenty of places that it's just not convenient to get wiring to. Wi-Fi is going to be, you know, the key thing for you to be able to get to that stuff. But when you're far afield, you know, looking at these, you know, towers and top of the wellhead, things like that, cellular network is going to be the way to go. 4G today, possibly 5G tomorrow, maybe lower WAN. So we're experienced with those kind of deployments. We can walk you through the options, talk to you about backups and failovers and things like that. Generally, it's best to not have just one way of getting to your data. Try to get that stuff in a timely, secure manner.
Yeah, and another case just to throw out there for people that you know, are maybe not doing remote sites. One of the things that's really cool about cellular is that means that you're not on the customer's network. So if they're not going to let you on with whatever reason, cellular can be an easy workaround for that problem to solve.
Yeah, absolutely. I jumped the next slide a little bit quick. I got to show off my two new babies. I'm not a salesperson. I don't get commission. This is just me. Really enjoying the fact that we can hit a lower price point as an industry and specifically as OnLogic. ARM processors, we're using an industrialized Raspberry Pi compute module in our brand new Factor 201. Really good little gateway. Get access to your stuff that's, you know, perhaps not as intelligent, a little bit older, in a very cost-effective way. We have an Ignition special unit for this. It's already pre-installed with Edge. And then we've got something that looks a little bit similar, a little bit bigger of a form factor, which is going to give you some digital input output, some analog in, even some temperature sensor stuff. Starts kind of getting into the area where some of the PLCs play. Gives you a lot of different options in terms of how you can interface with your equipment and your environment. And again, you know, this is coming out soon, and it will be preloaded with Ignition Edge, ready to go out of the box.
Yeah, and while we still got a whole range of x86, like you said, Mike, and like we said earlier in the presentation, the ability to start deploying and seeing the value of data right away for a really effective price point, but still industrial, is really, really cool. Like these, you know, talking to people at ICC, I know a number of folks are running perspective on these and then just connect it to a monitor if they have a mouse and keyboard, just to get started. You know, you've got the additional functionality, you've got everything you need there. So it's an interesting way to try to, you know, get as, you know, a lot of systems out there for a lower price point, but, you know, still reliability. Back when it was, you know, only Intel processors, that was all great, but we couldn't lower the price point beyond a certain threshold and still keep the reliability. So
Yeah,
ARM allows us to do that a little different.
Absolutely. And let's talk a little bit later about how we can get people started, because I agree with you. You know, getting that proof of concept out there, starting to find the value of Ignition software, of hardware, you know, that survives at the edge. That's all really interesting. So I love proof of concepts, but I need to turn this back over to Travis to talk about software.
Yep. Yeah, absolutely. And as there's hardware considerations, of course, there's also software considerations, and that we have to look at. You know, really, software needs to be able to scale. You can always scale by adding more, but when it's built in, when you kind of think about it at the beginning, it lays that groundwork, right, for low cost scaling. It's just about adding more to the system, and that's Ignition's fundamentally want to get out of your way. So we have the compute that's there. We can get out of the way with both areas and get more data, do more functions, and have more available. And you kind of got to think about the future, which we'll say here in a minute. But you also need to figure out how and where you're going to get your data and where it's going to need to go. You mentioned the connectivity in terms of like cellular, 4G, and wireless and all that. That's obviously very important on the northbound, getting it out. But we got to look at the southbound, right? What are we talking to? Legacy PLCs. What protocols we're dealing with? Is it OPC? Are we going to be sending data through MQTT? Are we going to the cloud, going through cloud connectors? What does that all look like specifically? Having kind of a roadmap, a detail of what we're going to go. It makes for a much smoother system. And then last, of course, do you have to have redundancy? How critical is the system? You have to, do you need that redundancy or that failover? So those questions change, what you look at in terms of hardware. If you're looking at from the application side, it all goes together. I think looking at these all at once is an important concept. A lot of people come to us, look at some considerations, and then we stop there, right? And then they may go to OnLogic, how its considerations. We can all talk together about what's really needed with this.